Now, after we have cached our simulation here, or our compressed cache, let me talk about creating the whitewater simulation for this splash here, or for this collision. So here in this file cache node, I will load from disk, and here is the cached simulation that I have made. Okay. So now to create the whitewater simulation from the shelf tool, you need to go to the particle fluids tab and select the whitewater. You need to select the fluid for generating the whitewater. So to select the fluid, you can enter the DOP network. Okay, go to the frame 35. Okay, the viewport stop now. Oh my god, what happened here? Just go to the initial frame, select whitewater, select the fluid. Okay, so now it selects the flip tank object. Press enter. Okay, now I have to hit escape because this started the simulation from the first frame and it continues to frame 35. So here is the whitewater node. There is a DOP network where the simulation happens, a node for importing the simulation from the SOPs, from the DOPs to SOPs, and a node to source the whitewater. So let me talk about the whitewater source here. Okay, so here we are merging, our object merged the compressed cache node here. Okay, and then there is this whitewater source node, which sources which makes the source of the whitewater based on some attributes. We have our curvature, acceleration, vorticity. Okay, so if we just jump to frame 74, it's working on it. So here is the whitewater source. As you can see, it just isolates some areas of the simulation, and those areas are based on the curvature and the acceleration, the vorticity. You can choose those three attributes together, or you can choose one of these attributes. So here we can use the curvature, which is the amount of curving in the simulation. So when there is a splash and the water is more dynamic, surely there will be more curvature, because there will be dynamic shapes and dynamic splashes. So here we emit from the curvature, and we isolate the range from 8 to 10. So a particle should have a curvature of 8 at least, and a curvature of 10 is the maximum value, and so values below 8 will not be isolated, and values above 10 will be isolated. So this is the range of isolation. You can just adjust this range and have different values and have different results. Okay, surely when you increase the range here, you will have less areas isolated, but I will use this default, and you should know what is an acceleration. The acceleration is the amount of change of speed. Okay, so when there is splashes and dynamic motion of the fluid, there is too much acceleration, and the fluid changes its velocity because of the collisions and interactions between the particles. Okay, so this acceleration range from 30 to 60. Surely you can increase the 60 or increase the 30 here. If you just adjust this to something like 50, the particle needs an acceleration above 50 to be isolated or to be used as a source of white water. And vorticity is the amount of curl and rotation that happens in the fluid, and this ranges from 20 to 40 by default. Okay, I will use these default values for now, but you can do a lot of tests and a lot of tests and a lot of R&Ds with different values here, and you can choose the values that you want, but I think those values fits for me now. And surely the voxel size here is just the particle separation multiplied by the grid scale, and this is by default. I don't change this at all. You can cache, or you must cache this white water source onto disk, because if you don't do this, it will be simulated, or it will be cached every time you do the white water simulation, and this will consume a lot of time. So you need just to recache this onto your disk and load it from there, and don't start your white water simulation unless you have just finished the white water source cache. Okay, surely this can be heavy and can consume a lot of RAM, so I don't encourage moving a lot at the viewport while there is volume visualization here. Okay, so this is the white water source. In the next video we're going to talk about some of the white water simulation parameters, and we are going to talk about the changes that we will do to these parameters in order to get the result that we want. So thank you for watching.